Now, basic proportionality theorem. This is the first theorem, that is theorem number 6.1. It is based on the similarity of triangles itself. This theorem as well as proof you need to study. Statement is like this. If a line is parallel to a side of a triangle which intersect other two sides in distinct points, then the line divides other two sides in proportion. Proportion means the same ratio. If a line is drawn, this DE is that line, DE is that line drawn, this DE is that line drawn parallel to the side, which is side BC, that is a side of triangle BC, is that side parallel to that BC. After that, that DE, that intersect AB, if that intersect AB at the point D as well as AC at the point E, then that line divides that two sides. That are the, which are the two sides? AB and as well as AB as well as AC. This line which intersect that two sides, no D and E, that particular points. These two sides are divides, that line divides these two sides in the same ratio. That is AD by DB equal to, that is AD by DB equal to AE by EC. AD by DB equal to AE by EC. This is basic proportionality theorem. Then what is converse of BPT? Converse of BPT, converse of a theorem means given become to prove become given. So if a line segment intersecting the other two sides on two distant points divides them in same ratio, then the line is parallel to the third side. That means the ratios are equal here. Then this is parallel. This is a converse of BPT. Theorem 6.1, that is BPT. We are going to prove that theorem. So first step, the statement is as if a line is drawn parallel to one side of a triangle to intersect the other two sides in distant points, then the other two sides are divided in the same ratio. This is the statement of the theorem. What are the things given there? Given that ABC is a triangle given, ABC is a triangle given, and DE parallel line that are given. So ABC is a triangle which DE parallel to BC. These are the things given. Then what you are supposed to prove? We have to prove that ratios are equal now. So which are the ratios? AD by DB. AD by DB equal to AE by EC. AE by EC. That should be proved. Then for proving this theorem, we need to draw some extra lines. That is construction. Okay. That construction, which are the constructions here now? First, we have to join BE and CD. First, B from BE as well as CD. These two lines you have to join. Then you need to draw two perpendiculars. That is DM. Perpendiculars DM, one perpendicular DM, and next perpendicular EN. From E to N, that is perpendicular to AB. So which are the two perpendiculars drawn there? That is one is DM perpendicular to AC as well as EN perpendicular to the side AB. So these are the constructions for two lines want to join, two line segments, then two perpendiculars also want to draw to prove the theorem. Next, proof. To prove, you need to consider areas of triangles. Here I want to consider first triangle ADE. We are going to find areas of three triangles and ratios dividing. Okay. So first step, area of ADE. This is a triangle, green color shade let us given ADE. This is the triangle ADE. This triangle area you can find what is the formula for finding the area of triangle? Half into B into H. Half into B into H. If you are taking AD as the base, here AD is the base means AD is our triangle. So E is that vertex opposite. From that E, perpendicular drawn is EN. So AD into EN, that is half into base into H, that is ADE. Then similarly, again we want to consider the triangle BDE. This is a triangle BDE. BDE. This is a triangle BDE. In the triangle, also area want to find half into base into height. Here consider this DB as the base and our triangle is BDE. So from the vertex E, the perpendicular drawn to the side BD, that perpendicular is again EN. It is an extended BD, that side extended line segment, that is N is lying in that line segment, that is AB. So EN is a perpendicular drawn from that vertex E to the side DB or AB. So EN is the height and DB is the base. So area of the triangle BDE means half into DB into EN. And area of triangle AD is AD into EN, half into AD into N. Dividing these 1 and 2, if you divide and necessary cancellation, this EN and EN get cancelled and at last we get that area of ADE by area of BDE is equal to AD by DB, 1 ratio. Then we have to consider next set of triangles, again ADE itself. In that ADE, but there you have to consider ADE and AE as the base. Here the same triangle ADE, and in that AE as the base means if this is the base, means the height will be DM, that is perpendicular drawn from the particular point D to that side AE, that is DM is the perpendicular. So formula area is half into B into H, so half into AE into DM. This is the formula. Then next DEC. This is a triangle DEC. DEC, this triangle. In this triangle, EC, take that EC as the base. If that EC is the base means the perpendicular had to drawn from where the point D. And D to the side EC means that perpendicular is DM. So half into EC into DM. This is the area. Here AD is half into AE into DM. Similar for this same step, here you want to divide this two areas. So when we are dividing these two areas and cancelling the common number here, that is DM and DM get cancelled and will get as a ratio AE by EC. Now triangle BDE as well as DEC. Triangle BDE, this triangle as well as DEC. DEC means the same, this triangle. These two triangles are in the same base. And between the same parallels. Here the base are the same base. Here the parallel DE as well as BC. These are the two triangles. Inside these two triangles, same base and same parallels. That means that two areas are equal. That is area of triangle BDE equal to area of triangle DEC. That is a triangle lie between the same base and between the same parallel having the same area. So previous ratio, that is area of triangle ADE and by BDE can be written as ADE by DEC. So there AD by DB first equation and AE by EC second equation we get. The two are from A and B, the two equations we can tell that AD by DB equal to AE by EC. Hence the proof of this theorem.